Hello my dear students, I welcome you all in your favorite Dear Mathematics YouTube channel. So before starting the lecture, I want to tell you that if you found these lectures are important for you or helpful for you, please subscribe the channel. This will motivate me. Okay, so in the previous lecture, we have studied the definition of metric space. Okay, and we have we have studied about the literature of topological space and metric spaces. Okay, so after the definition of metric space, what we need to study is about the open set of that space or open set of that topological space or any metric space. If we studying the metric space, that means we are studying about the topological space. Okay, and important thing is to remember that for any space, for any metric space or any topological space, the most important part of that space is open sets. Example, for any human body, the most important part is heart. Okay, so for similarly an open set or open set of all open sets of any topological space or metric space is actually heart of that space. If you can study all open sets of that space, that means you have studied almost everything about that space. So you can imagine that how important is this open sets, study of open sets. Okay, so now we have to study open sets. So for any metric space, to give the definition of open set, we first have to know the definition of open ball. Okay, because in reanalysis, since you are now seeing the lecture of topology, so you must have studied reanalysis. So in reanalysis, you have studied that to define an open set, you first have defined open neighborhoods. Okay, so hence similarly here also you have to study first of all open balls to study the open set. So let me first give the definition of open balls. Let X be any metric space. Okay, and now suppose let X be any point. We are fixing that X belongs to X and any R. We are fixing this R that is greater than 0. We are fixing this R for distance. Okay, means for radius of that ball. Okay, so for any X belongs to X and for any R greater than 0, the subset, means we are defining a subset. The subset, and we are naming that subset as a Bx comma R, which is defined. This is notation of defined dot dot equal to. This notation is how we are defining this set. Now this is set. Okay, defined as Y belongs to X such that distance between X comma Y is less than R. Then this Bx comma R is called open ball. Let us visualize this definition. Okay, here let us visualize what I have written. The visualization is, suppose XD is a metric space. So now what is X? X is actually any non-empty set. Okay, let's say this is non-empty set X. Okay, and D is distance. Okay, so what we have obtained, suppose let any X in the definition, any X, suppose this is X point. Okay, and what we have given that any R is greater than 0. Then we have considered a subset Bx comma R. How we have defined this Bx comma R? We have defined this in such a way that we have in this set we have taken all those Y of this X. Okay, such that Dx comma Y is less than R. Suppose that is all those points of X which are less than R distance from X. Suppose it is R distance from X, and similarly in every side you can make R distance. Okay, Okay, suppose we draw this one, this circle. Now all these points here, all these points are actually y. Y belongs to s, such that distance between x and y is less than r, and this whole thing is defined as that bx comma r is called a open ball. So you have understand that if any x d is a metric space, then all those subset which defined in such a way is known as actually open ball. Okay, so now let us move towards the definition of open set. Okay, so in the definition of open set, that is open set definition, so we have studied the definition of open balls, and now we will use that definition to define open set in any topological space or in a metric space. Okay, let's suppose suppose which set we will call as open set. Suppose we are considering U is a subset of X, and we are telling that U is a open set of X. If now U is called an open set of this X, if what will happen if for any X belongs to U, there exists an R greater than 0 such that B x comma R is subset of U. Means, let me give the visualization of this definition. Suppose this is X, okay, and now what we suppose this is U, because for U there is any U can be called as open set. When it will called as open set, suppose any U will known as open set if for any point of that U, if we consider if we get an open ball around this of any radius r, because there exists any r, this any radius r, that should be inside the U. Okay, that ball should be inside U. So now suppose you consider this point of this U, then there must you should get a ball. Suppose you consider this one, you must get an open ball. Okay, so all those set in any shape, all those set U will known as an open set if for any X belongs to U, you can give a open ball inside that U, then it will known as a open set. Now my claim is every open ball is an open set. So we have seen the definition for open set. Now we have to show every open ball is also open set. That means we have to satisfy the properties for open set. What we have seen for open set, that any set U is said to be open set if for any X belongs to that open set, we must give an open ball inside that open set, totally inside, then only that U will be known as a open set. Now our claim is all those open balls are also open sets. Now we have to show that for every open ball there is again an open ball inside that open ball, then only, right, then only that open ball will be open set. Okay, so now the definition for now what I am claiming, that suppose U is an open set, so that means B x comma R, for X belongs to U, there exists B x comma R such that B x comma R is inside U. Okay, now I have to prove that B x comma R is again a open set. So we have to show for any Y belongs to B x comma R that B y comma delta is inside B x comma R. That means we have to show there is an open ball inside this open ball bx comma r, then only this bx comma r will satisfy the open set property. Then only we can say that bx comma r is a open set. Okay, now let me give you the clear visualization of the definition. Okay, suppose this is x. Okay, now suppose this is u, this is u open set. Okay, and suppose since it is open set, suppose this is any point x, so obviously we can give an open ball inside this. This is the definition for open ball, that all the point in this set, in this circular set, that is open ball, is at distance less than r. Okay, that's why it is in a circular position. The means open ball shape is circular position, but for any open set it need not be. Okay, so now we have to visualize this one. Suppose if we magnify this one, that is this one, now this is actually our bx comma r. Okay, that is inside is x, and from every side it is at r distance. Okay, from every side it is at r distance. Okay, now suppose any y, if we take inside this bx comma r, you have to show that we can again get an open ball inside this bx comma r. Okay, so let's suppose we draw a straight line between x, y and r. Okay, now this distance actually is up to here is actually r minus dx comma y, because from here to here, this y point to x, the distance is dx comma y, and total is r. So this part from this to this part, the distance is r comma dx comma y. Now it is our safest zone. Now if you draw any open ball around y, just see this. If you draw any open ball, so from y to this side, we have long safest area, but from y to this side we have little safest area. Okay, because after some time we will cross this bx comma r, but our open ball should be totally inside the bx comma r. That's why if you take any distance, or any in place of r, if you take any delta, any distance for this inside ball, okay, in between 0 comma r minus dx comma y, then you can imagine that any ball around y, since this is y point, with this distance delta. Okay, now which delta we are taking? It is means this to this, in between this, means from this point to, we are taking such distance which not crossing this our bx comma r. Then this open ball will obviously always be inside bx comma r, because in such a we have taken our delta. So what we have proved? We have proved that for any open ball bx comma r, we can always give an delta distance, such that we can give another open ball inside that open ball bx comma r. So this is satisfying the open set properties. Hence bx comma r is an open set. That means again this by comma delta will be an open set, because we can again draw inside this circle same magnifying definition. Okay, so what we have proved? We have proved that every open ball is an open set. So we have studied with open balls. We have defined open set definition with the help of open balls. Now we have again proved that every open ball itself an open set. So what we have concluded? We have concluded that any open set is nothing but unions of open balls. Why? because if we take any element of that open set, we can give an structure for open balls which is totally contained in that open set. So obviously if any arbitrary x belongs to open set U, we can give any bx comma r, that is open ball inside, totally inside U. So what is U? For any arbitrary r we are getting an open ball, so totally U can be written as union of all open balls for R, for some R belongs to R and R greater than 0. Now we will see the definition for closed set. Okay, closed set. Now any set F or subset of X, any set F subset of X is said to be closed set if X minus F is an open set. Can you understand? Here it is saying that if any set F is given and complement of that F, if that is an open set, now we know the definition for open set. So now if we study the only open set, then obviously we can give the structure for all closed sets. Okay, because if we have all open set, we will take the complement, that will be our closed set. Or any set given, and if we take the complement and if we find that that one is open set, because we know the definition for open set, then we will obviously tell that that set is actually closed set. Okay, now the most trivial set are empty set and whole set X itself. Now these two sets are both open and closed in X. It is your homework, or in the next class I will show you that how these both phi and X are open as well as closed in X. Okay, just try this. It is your homework. Thank you so much.